Here is Stephen again. Let's continue on part 1 of MECH215 Mechanical Engineering Design. This will be a rather short part. After I cover the basic mechanism of a motor, I'm going to go through again the main factors of a motor, then categorize of different motors. Electrical motor convert electrical energy to mechanical energy, which is the most common way of getting mechanical movement. The other options are petrol engines, and also some people use hydraulic or pneumatic drive to get this energy. Electrical motor operates through an interaction between the magnetic field and also a coil. So the mechanism is very similar to an electricity generator. It works the other way around. Electrical motor has a lot of different varieties. This picture shows many different options. If we have a coil showing this figure as the red rectangular shape with current going through, and then this coil is inside a magnetic field, then because the electrical magnetic interaction, there will be force generated on the coil. So the coil will start moving. The force is depending on the magnetic flux density B, which is how strong this magnetic field is, and also proportional to the current, how large the current is going through the coil, and also how long is the coil. So that's the length of this rectangular shape. So these three things will contribute to how large the force we can generate. When the force is turning into kind of rotation, that's torque. So this is also decide the size of this motor actually is more proportional to the torque it can be generated, because you need kind of long wire to cut through those magnetic field. The cooling condition is critical for a motor design, and it determines how much power a particular motor can generate. Because you can see we can increase the current going through the coil to generate more power, as long as there's enough cooling condition to dissipate the heat generated through the process. If the cooling is, we'll say, perfect, if we have a superconductor here, there's no power dissipation going through the heat, then basically we can have a motor generate super large power. There are many good internet resources explaining how DC motor works. These two animations shows very clearly the mechanism behind DC motor. So you can click one of this link and have a look. We have mentioned this slide in part 0 already. Because it's very important, I'll just go through this again. General property of electrical motors. One of the most important formula for electrical motor is P equal to T omega. P is the power of the motor, T is the torque, and omega is rotational speed. Normally we represent in RPM, means how many revolutes per minute. The torque of the motor is also proportional to the B bar, A bar, D square L. So B and A is specific magnetic and the electrical kind of design of the motor. So it's kind of the structure of the motor. D is the diameter, L is the length. So if you think the motor is kind of a cylinder, so D square and L is the volume of the motor. So you can see the torque is kind of proportional to the volume of the motor if the design of the motor are similar. So the torque implies the size of the motor, how big the motor will be. And also if we look at P equal to T omega for a certain power of a motor, if you have higher speed, means it has less torque. So it's kind of a balance between, do you want to have higher speed or less speed with higher torque. And also this will come to a design limitation for the motor. So let's introduce another variable Q, which is the power per unit rotor volume. So basically power per volume of the motor. So it means that with a certain volume, how much power it can generate. If we put the first two equations together, this is proportional to the omega, which is the speed of the motor. Which means if we design the motor with higher speed, then the power per volume will be large. And we should not design a motor with very slow speed, which means because for the same power, we have to design the motor very large size. And this leads to why all these mechanical systems, we have gearbox after the motor for a certain application. Because the combination of the motor, high-speed motor, and the gearbox for the reduced speed is going to be smaller and more economic than you design a motor with very slow speed and just use the motor by itself. And economically, that's much beneficial. That's why we have design a motor and then the gearbox. The electrical motor can be categorized into two major types, the DC motor and AC motor. There are two more subgroups in each one of these motors. For the DC motor, you have a brushed DC motor and a brushless DC motor. For AC motor, we have a synchronized AC motor and a asynchronized AC motor, which is an induction motor, and which mostly will refer to squirrel cage motor, and it's mostly three-phase. So three-phased AC induction motor is the major, kind of most important motor we use in industry. You must have heard about other names for motors such as servo motor, stepper motor. I put two links of good videos to explain the mechanism and the principles of those two motors and the difference between these motors. So basically, these motors are mainly used for high precision position control. So all the previous motor or general motor we're talking about is for speed control, to generate certain movement at a speed. We don't really stop the motor at each accurate positions. However, for servo motor and stepper motor, we use them mainly for position control. For example, if we have an industrial robot, you have a certain linear movement you want to achieve, then in those cases, you need to make sure the motor actually only move for that certain distance, not move continuously. So we need to have additional sensor and control mechanism to come together with the motor. So this motor is not just the motor itself, it's the DC or AC motor plus certain kind of feedback control. This is the last slide of part 1. After this part, you should think about two questions. First is, what is relevant or the major impact of the size of a motor? Is that torque or power? The second is to remember there's 4 major types of electrical motor. I'll see you in part 2.